Good morning, I'm Charles Rodetsky. I'm with Virtustream. And this is the wrapper formulas talk. Put your formula in a formula so you can orchestrate your orchestration. Virtustream is a member of the EMC Federation. We provide infrastructure as a service. We provide object storage and managed services. We deploy mission-critical enterprise workloads such as SAP and HANA into the cloud. I work with a group called Platform Engineering. We deploy and manage Apache Mesos Platform and an OpenStack platform. At Virtustream, we have over 15,000 managed hosts. They're managed by Salt across over 25 sites. Each site has its own Salt master. We manage a multi-exabyte object storage. We manage VMware, OpenStack, and Apache Mesos. I'm going to go over a quick review. Last year, Stephen Gonzalez gave a great talk about how we moved from a monolithic Salt Stack repository to individual formulas for each application. And when I started over at, I was EMC before we moved over to Virtustream, we had great deployment automation for our object storage. And we deployed like 5,000 nodes in a little over a week. But we had no operational automation. And we were stuck searching across 5,000 nodes for logs. We had no remote execution. And so we deployed Salt Stack primarily for remote execution against our object storage platform, against the front end, so that we could look at error logs and really get into what was going on with each request. Over time, we built up some states and pillar data and started using Salt as more of a configuration management platform. And we kept everything together in one big repository. And it's probably still a pretty common practice to do it that way. It worked reasonably well for a single project. We ran into some difficulties. It was tough to test because everything was in one repository, and where do you even begin when you're testing that? You have to test the whole thing or write individual tests against each little piece. And it was difficult to deploy. We were rsyncing things around. It's not really optimal. So testing consisted of clone the Git repository, rsync it up to the lab, run a couple of states against the lab, make sure everything still worked, upload the same data up to our production Salt masters across 8 sites at the time, and run the same states and hope everything still worked the same way. So again, that was really not optimal. We needed to find a better way. And it became even more obvious when another project started up. We had to basically clone our existing repository into a new one and make a bunch of modifications to get it to work there. So all of our reusable pieces like SSH, like resolve conf, anything that will be later moved into a formula was drifting between projects. So no longer did we have the ability to just keep a consistent set of states. So we had poor code reuse, we had divergence across the projects, and everybody was writing things in their own way, so nothing was consistent. So we came down to individual formulas. And the first thing we did was we took all of the most common states, the NTP and resolve conf and Salt, and put those each in their own formula with their own maps and brought it all together that way. A formula is a single Git repository that contains a tightly coupled set of states and orchestration to manage a single application. It includes the state and execution modules because generally those aren't going to be as useful without the state, and the state's definitely not going to work without the state and execution module. So this solves our code reuse problem because it's easy. So it's way easier to just clone somebody's formula and put it in your own project, and then everybody can reuse the same thing, and if improvements are made, everybody gets the benefit of it. We packaged them with Debian so that we could solve our distribution problem. Now we just stick them in an apt repo, and everybody can pull from the apt repository. again, we bundled the state and execution modules, so those get installed with the package. Everything's version controlled. We can have easy peer reviews across a small amount of code instead of a large. And the pillar data is still stored with the project. So we're leaving ourselves with a monolithic pillar setup. So to facilitate this and to really get the design patterns to be the same, we used an app called Cookie Cutter, which is a small Python application that allows you to define your whole project in Jinja templates. And the templates help enforce the design patterns by making it easy. You know, you make it the path of least resistance, and that's where everybody's going to go. So once we get there, the Cookie Cutter defines everything from your Debian packaging to the structure and layout of your formula. So you can have every formula be able to run make test, make Debian, make clean, and that makes it super easy to integrate with the CI/CD platform of your choice. I'm not sure how well that's going to come out. All right, so this is what one of our formulas looks like. We see the make file, a Vagrant file, so when you start developing on it, you can test everything right in a Vagrant. We put our modules in there, and there's all of our Debian packaging bits, and what actually gets installed on the Saltmaster is the Marathon directory and the underscore modules directory. And below that, we have the test directory that has all of our integration unit tests and some sample, or not sample, but whatever pillar data and salt data is required to test your formula. So for example, if you're using a MySQL formula and you need to be able to deploy a master and master and a client, you can set up the top file to designate one of your slaves as the master and one of them as a client. Let's see. So then we brought it all into TeamCity, and every time we want to make a formula, we can just use a template because all the formulas are tested and built the same way. So we just use a template. We have to define a few minor things like the Git repository it lives in, the repository it's going into, whether it's testing or the production. And then we can run any tests. We go back here. You see I have a tox.ini, so you can run any tests that tox finds. And another cool piece of it is when you make a pull request, before any code review even happens, TeamCity will run the tests against it. So you can know when you're reviewing code whether or not it passes all the tests that are defined for that formula. We're up to 140 plus formulas built this way. Our SRV salt, which used to be gargantuan, is slimmed down to 6 directories, including a top file. And formulas, SRV formulas, which is where we install all of our formulas, separate file root, is too big to put on a slide. Anybody have any questions about that part so far? The question was, do we use Git? Do we use GitFS? So GitFS, when we first started with this, we didn't have the ability to have multiple bases from GitFS. So it was all or nothing, and we wanted to get away from the monolithic repository. Beyond that, not all of the sites have access to our GitHub from network isolation.
So it's nothing, it's all just static.
So it's all Debian packages. That's how we distribute it. Yeah.
Do you use environments that install different versions of your formulas side by side, or do you not really?
No, we really haven't needed to do that. And I'll get into a little bit more why that is as we go further. How do I deal with pillar data with the formulas? So the pillar data belongs with the project at this point. So our production repository is a project. And that contains all the pillar data that applies to all the formulas.
So you store those on the salt master, or you package those up?
Those are packaged up and deployed to the salt master that way. Actually, the salt formula that we use deploys not only formulas, but pillar data also.
Formulas broken out into your own repository, your keys that you got and everything. How do you manage possible interdependencies between your formulas for testing? If formula A has changed and 3 others depend on it, how do you determine that there might need to be additional tests running against additional repositories?
Right, so the question is, how do we determine, or how do we do testing against interdependent formulas where, say, our Docker formula relies on Python? So we just build a link to it in TeamCity that says, if there's a change to the Python formula, also test Docker.
So you have a separate job for each repository?
Correct. We have a separate pipeline for each repository. Anyone else?
So you install all formulas into one directory, right?
Correct.
Do you handle somehow possible name conflicts between formulas and files inside them?
So we haven't had that problem. I don't think we've come up with a solution to it since we haven't run into it. But each formula gets its own directory under SRV formulas. So for the marathon formula, for example, it'll be SRV formulas marathon. And modules live under SRV salt _ modules. So yeah, we could possibly have a conflict there, but it's not something we've run into, so we haven't really addressed it.
And another question, do you find any reactions inside your formulas?
No, we haven't actually worked with reactors much at all. Mm-hmm. Anybody else? And the question is, do we install our Debian formulas as Debian packages? And yes, we do. That's how we handle the distribution, so we don't have to rsync things around anymore. The question was, is that one Debian package per formula? And yes, it is. So our salt formula has a list of whatever formula packages need to be installed. And so it iterates over that list with a package installed when we high state the salt master. Right, so the question was, on the salt master, how do we determine which formulas need to be pulled down? And that's done with pillar data for the salt formula. So we have a salt formula that accesses pillar data, and it has a list of all packages, all formula packages and pillar packages that need to be installed on this master. And it just iterates over that.
It sounds like each master is completely separate autonomous environment. Is that not correct?
That's not correct. So production is an environment, and it has its own pillar data. And that pillar data goes to all 25 of our production salt masters, right? Assuming that they're related to the same pieces.
Can you say a few words, how do you test your formulas?
Oh, sure. So the question was, how do we test our formulas? A lot of it is done through Fabric. As part of our template, we stand up a Vagrant VM, and then we can use Fabric to run tests against anything we did in there. And we also use unit tests for our modules and our execution and state modules. And that's just run via nose tests and talks.
You define some conditions which Fabric checks, right? Is this port open or file present? Where do you define those conditions?
So the question is, where do we find those conditions? And that comes back up to here. We have the test directory with integration and unit tests. We define all of our tests in there, and Tox picks them up and runs them. So, and that's all done through Fabric, and we started playing with env assert as well.
Tox runs
Right, Tox will run a command we tell it to run, so.
Do you handcraft the tests, or do you generate them from the formulas?
At this point, we handcraft the tests. Especially when we need to do things like mocking and.
So,
Alright.
you said that Tox runs Fabric. So Fabric, your assertions about whether stuff works or not, they are in Fabric scripts or where they are?
Right, they're in either Fabric scripts or within env assert at times. I need to move on so that we can keep going here. I apologize. All right, so what don't individual formulas solve? They don't do anything for interdependency between formulas. So we'll have, say, Zookeeper and Mesos. Mesos depends on Zookeeper, but there's no way to define that in either formula. So there can be reusable pillar between or within a project. So sticking it in that monolithic pillar doesn't do anything for reusability of that data that would be the same no matter where you deployed it. If you deployed it in the lab, or you deployed it in production, or you deployed it in some OpenStack VM somewhere. And it doesn't allow testing of the live pillar data, since that's kept in a separate monolithic repository. Enter wrapper formulas. This captures a single platform or product, and it ties the individual formulas together. It ties together their orchestration, it brings all the pillar data, and each state has to bring its own orchestration that can then be tied together. So, for example, a clustered application like Zookeeper brings any orchestration required to turn up Zookeeper and deal with all of its clustering mechanics. And the orchestration state includes that orchestration and then extends it to enforce any order you need. And here's an example of where we included all of the orchestration states required to deploy our container platform. And this is where we extend. So we have extend, resolve, manage. This is actually a stanza name. And then we require salt high state. And if we look back here, we brought in ext tw orchestration salt. Within there's a stanza called salt high state. So before resolve manage is allowed to run, we have to have completed the high states. Same with zpool, requires that the high states have completed. And before we start Docker, the zpool has to be up and any symlinks have to be created. We link in varlib Docker onto the zpool so that we have plenty of space to launch Docker containers. So formulas bring their own orchestration as needed. The wrapper formula brings all non-environmental pillar data for the platform, and it allows testing of the entire platform, but it doesn't break our individual formula model where we can test those individual formulas. So we don't have to take a step backwards to be able to think about a whole service instead of just an application. We install to a known location. We install all of our wrapper formulas go into SRV salt ext and SRV pillar ext. This is so we know that it was installed by a wrapper formula package and which package installed it. And now we can turn up a whole stack with a single command because we tied all of those formulas together. That allows us to layer, first do a high state, then do zpool, then do Docker, then do Zookeeper, then do Mesos, Marathon, etc. And the Mesos platform was our flagship wrapper formula. Runs on bare metal in production and staging. It runs on OpenStack VMs and Vagrant for development and testing. And that uses the same pillar data, the same formulas, the same everything. So we can be sure that when we're testing, when we made a change to the pillar data for this platform, we're seeing the same thing in development as we're seeing in staging, as we're seeing in production. And Chad's talk after this one, it's not called Mesos as a harsh mistress. but but it's the lessons we learned while deploying Mesos and why we did what we did. And that's coming up after this one. And that'll give you more details on what we did. So next steps, we have better output. So if you've ever seen output from a state that's run by orchestration, we spent more time during the deploys of this platform trying to find where the failures were than we did fixing the problems. So we need to find a better way to parse the output. We want to do full platform testing via TeamCity. We don't have that today, but we've recently gotten to the point where all of our OpenStack turnups of the development and testing environments are 100%. So getting that to be within TeamCity and have that as another link, right? Like if you change Docker formula, make sure that the platform's still built, and that sort of thing. And we still have the OpenStack project, the Object Store project, and the core infrastructure project that we want to migrate to a system like this. We don't have that today. And then we want to get into this event-driven orchestration. Apparently, there's a new piece called Thorium that supports this, and it really seems like the way to go. And that's it. Any questions?
So you focused a lot on formulas, and it looks like all of this is like internal stuff, and largely that's probably because of how you're delivering these embedded packages. But like, how much of this can be contributed back to like the community maintaining formulas, and how much of those do you provide in your own?
So the question was, a lot of this looks like it's very specific to our internal orchestration and our internal setup. How do we plan to contribute that back, and do we contribute any of that back? At this point, we do not. We are working through management to try and get it so that we can.
What happens if you have to deploy like Mesos, say, and you can also deploy Kafka and invoke Zookeeper? How does that consider?
So the question was, what happens if we have to deploy, if we want to deploy Mesos and we also have to deploy Kafka and other services? Do you mean on the platform, or?
Yeah, do you end up with two different Zookeeper installs?
So yes, we end up with two different Zookeeper installs. So Zookeeper, we're totally isolating Zookeeper for the platform from everything else because we definitely don't want applications writing into the same Zookeeper that keeps the state for our platform. Anybody else?
Last question. You mentioned network isolation and getting access, but how do you get Devins out to your isolated network?
No, they do have access back to the central Debian repository. Correct.
How are you distributing visuals for Pillar? Are they part of the packages or is it like system integration?
Right, so we use the GPG pillar for that. And so we store those with our project as environmental data because we don't have the same GPG keys in staging and the lab for decrypting those pieces. Anybody else? Oh, go ahead.
When you're using your real TeamCity for your dependent formulas, are you installing the Debian packages, or what are you just using the source code and running that in your tests for your dependent formulas?
So for dependent formulas, the question was, for dependent formulas, how do we actually install the code into our Vagrant VM for testing? And that depends. For the formula you're currently working on, we're going to use the source that's right here. We're just going to map that into the Vagrant container, or the Vagrant VM. For external, we're going to pull down the Debian package.
I think the key you mentioned there was that you actually run the Vagrant image in your TeamCity node, and that's why you can do it.
Yes, yes. Sure. How did we choose our testing platform? So we initially started with Go CD from ThoughtWorks. And that worked really well for quite a while, but it ended up just being rather slow in the end. So we started looking around and we found Team City. One of the great things about it was the commenting back to GitHub on pull requests and things like that, so we know that it builds. I'm not sure the other reasons behind that decision, but there are a lot of other projects that use within our organization that use Team City for their testing and deployment, so we just brought ours in with theirs.
How about Tox and Tabber?
So Tox, because it's already heavily used for testing Python, and we have a lot of Python in there, right? We have a lot of state and execution modules are all written in Python, so it runs nose tests for us and that sort of thing. We ended up using Fabric because we have to be able to get into the Vagrant VM somehow. And Fabric provides that.
How are you managing versions of the formulas going through your environments or through your projects from dev to QA to production? You have a Git version where you actually store the source code and you're creating a Debian package that has kind of a Debian version. How are you managing and maintaining that version as it goes through your environments?
Sure, the question was how do we manage and maintain the versions of our packages as they go through development and out to production. In GitHub, we have two branches. We have a development branch and a production branch. In our app repository, we have a testing repo and a production repo. When you make a commit to the develop branch, it gets tested and built and deployed into the testing repository. And when you make and then you have to go back and merge from development to master after you have tested everything. And then then that build chain kicks off and it puts it into the production branch.
So then does the production just always updating, or are you managing those versions actually in the production software?
Various ways. Most of the time, for a lot of them, we have them as package latest. But for a lot of them, we also use version pinning. So we make sure that everything's consistent. How long does it take to run our tests for a single formula? That varies quite a lot. Some of them are pretty quick. Those are usually the ones that people didn't write a lot of tests for. But so our salt formula can take up to 20 minutes to run because it does a lot of testing. It turns up a master, syndic, and a bunch of minions on various distributions, and tests that we can get all the way from the master of masters through the syndic master to all those endpoints over the HTTP API.
Are all those on our own Vagrant VMs?
And the question was, are those all on their own Vagrant VMs? And yes, they are.
So you mentioned that you use latest when you're updating your Debian packages. How do you handle rollback?
That's why we don't always use latest. But we would handle rollback by pinning the version to the previous version.
So with ones that you have latest, I guess you could always roll back by rolling forward with Git.
Yes.
Or if you use version, you could roll back based on which are you going for?
I would say that most of the time we would just update the Git repository because a lot of the time, if we had a problem with that version, we would just want to fix whatever that problem was and keep the concept of where we were going.
You mentioned that you distribute Untitled Chapter the formulas. From what I recall, Salt doesn't have wildcard rules and pillar top files, so how you make them available? You build top file each time as part of your Debian package?
So we do some interesting things to get around that. We actually target a lot of our stuff with pillar. So we'll define a role for a server, right? This will be a role Mesos master true, and that'll be a pillar. And Then we can assign pillar data from them. Then we can assign states to run in our top file from there. But generally, we keep our host naming consistent so that we can just keep one top file to cover all of that. All right. Thank you very much.